Good evening, everyone. My name is Najib Khouri-Haddad. I am one of the general partners at Sway Ventures. Thank you for making it tonight. This is the kickoff of our annual conference, Sway Minds, and I hope all of you will make it tomorrow. We have a full day, a very interesting day, very interesting discussions. Typically, we try to bring together our ecosystem players, our investors, our corporate partners, our portfolio CEOs, and entrepreneurs. The night before we do this kind of setup, it's a more private dinner, and there is typically a higher concentration of corporate players, and like to acknowledge some of them. They are in the room here, the Intels, the Ciscos, the Motorola's, the VMwares, and the Citibanks, and others. The corporate partners are very important to us. We usually spend a lot of time with them trying to compare notes on the trends in the industry, technology trends, the problems that customers are looking for, and try to compare notes on deal flow and where they are investing. I mean, as you may know, the corporate ventures is about 20–25% of the total venture capital invested. And I think companies like Intel Capital is probably one of the largest VC in the world. And every company these days is looking to bring more technology innovation into their products and services, because that is what creates value, that is what creates more services and automation and efficiencies. So we try to spend quite a bit of time with our corporate partners, try to get them to invest with us and us with them. One of our portfolio companies here, OnScale, Jan is the CEO of the company. They are building a cloud-based AI for computer-aided engineering. We invested in the company, and we hope to put even more dollars into the company alongside Intel and Google. And together we hope that we can create really a big, very successful companies. Now, those companies, the corporate, usually when they invest, there is typically a sponsor in a business unit or a product team, which means that for us, there is already a pathway to a commercial relationship in some of those companies, and down the road, they could be acquirers. So we kind of think of it as a life cycle management and really put the time and effort building and maintaining those relationships. So said that, and maybe a few words on the panelists here. I want to thank all of you for doing this tonight with us. I think I have next to me maybe 3 guys who have PhDs. I mean, this is a full room of PhDs between Michigan, where I went as well, and Imperial College here, and you did it at Brown, right? So very distinguished and good universities.
I won't hold that against you.
Football or basketball.
So maybe the topic that we have here on the wall behind us is really about software. And when I reflected about my own careers, when I started as a software engineer, and I was programming essentially a voice system that used to be called a CBX, Computerized Branch Exchange, or a PBX. And those were huge machines, and there was lots of software and hardware in them. And when I fast forward 20 years, you can do the same application with Skype or WhatsApp, which is essentially an app running on your phone. No hardware, nothing, really very easy, and most importantly, it's free. So I think lots of companies, when I hear the Cisco, the CEOs of Cisco saying we want to turn our company into a software company, which is a company that sells switches and routers and connectivity devices. I mean, there's a clear trend for having more software as a differentiator, as a value add, as essentially driving the revenue and the business models for most of the companies. And that goes for tech companies as well as for the industrial companies like an ABB or a GE. Every company is looking to have more software content and services in their product lines and services. So I think that is going to be the topic of the discussion today, and Ken and I will share this panel. Ken?
And we want to get to the guts and to the real smart people here. So I'm going to just say that, to set the stage a little bit, I think in the last month or two, Boeing realized that they're a software company underneath the covers. And I think that really speaks to the massive changes that we've seen technologically. And you either are a software company or you will be a software company soon, or you probably won't be around 10 years from now. And the enabling technologies that we've seen across broadband, across computing power, you name it, all of these enabling technologies have taken us to a different level and to a different stage. And so that's why I think this is a really important topic for a person like me that's engaged in some very traditional companies. If you look at my kind of resume and kind of the companies that I'm on the board of, not just tech companies, but big box retail or public safety. At the end of the day, all of those boards and those companies know that surviving and thriving going forward is going to be about the dexterity under the covers in the software space. And with that, why don't we dive in? One of the things that I'm interested in, and maybe I'll ask you to start, Naveen, is because one of the things I have great respect for is while you talk about and your expertise is in algorithms and driving, for more pure, more elegant algorithms to do stuff faster. You're one of the few people that I've known that actually has a dexterity to you have a hardware background and you have a massive software background, but you thread the needle, with your expertise in computation. Can you talk a little bit about kind of how you got there, how you got to that point?
Yeah, sure. I think my career started actually at Sun Microsystems. I was in the computer architecture group and building processors. I think I saw very clearly that to make a piece of hardware do something other than generate heat, you need to write some software. And the rest of my career was really around the intersection of those two things. And also after 10 years in industry, I actually quit my job and went back and got a PhD in neuroscience to kind of take it to the next level, which I would say making software do something useful is really about the algorithms. And that's kind of how the field of AI came to be. So it's really an interest of understanding the whole machine that actually solves a problem. A lot of folks get, I think, very almost pigeonholed, right? If you become a web developer, it's like you get lost in the tools and frameworks and all the things that are about back-end web design or whatever. But I feel like just never really losing sight of what it really takes from a machine perspective. What is a machine really doing all the way down, right? I guess my curiosity ended at sort of the device physics area. I didn't quite go beyond that, but I always like to understand what process is involved in actually serving a web page or making a spreadsheet work. So it's just kind of a curiosity, I think, really led me to that.
Yeah, I'd just like to amplify that a little bit. So, one of the things that the last 2 years of security history has reinforced is exactly the point that Naveen just made. You have to, in order to protect a system, to defend against an intelligent bad guy, and the bad guys are very good at their job, right? You really have to understand the entire system from the highest level of abstraction all the way down, in fact, to the physics at the bottom of the stack. And the name that we gave to that phenomenon was Spectre, right? So the fact, that you have this at the bottom of your phone, right, and of all these other devices, you have this processor that is basically doing a bunch of different execution pipelines in parallel, but it's not really totally cleaning up after itself, and it leaves a few little traces there. And the bad guy can use those traces, for example, to extract cryptographic keys. It's easy to think that not only, is every company becoming a software company, but that every company is moving to a higher and higher level of abstraction, and that what's really important is the interface. And there's a level at which that's true, but there's also a level at which it's really not true.
Well, and then maybe for myself, Ken, the reason I switched from essentially high-tech, 20 years at Cisco Systems, and now find myself in an industrial company is that what I find really appealing as a hardware/software guy is that we're essentially reinventing what I call the industrial operating system on which the planet runs. So we've had an industrial economy, highly centralized, big machines for over 100 years. It's given us tremendous benefits. Life expectancy has doubled. Inequality has been removed for vast quantities of people on the planet, even though there's still inequality. But I think, frankly, that the systems we have today are killing their host. And we have to essentially find a way to go away from highly centralized big machines towards highly decentralized local systems of production, which is what we used to have in an agrarian economy. The problem is, back then, life expectancy was 47, and most of you in this room would probably be dead by now. But we have to go to a world where we can expect to be healthy, productive, and not at the edge of famine. So what we have to do is find a way to coordinate decentralized assets, and the only way we can do that is with digital technology. So in terms of energy systems, going from large power plants towards wind farms, solar farms, small scale assets, which when they're aggregated can act as many, can act as one. And when I look at that, I'm thinking like, wow, from a software perspective, it's a fantastic playground in which to play, because we have to dabble with the very small, so the microprocessors and embedded systems that are in the sensors that are on these pieces of equipment. They then speak a variety of protocols and have to deal with all the cybersecurity challenges that Bob was talking about, to then connect to a gateway, which then in turn probably connects into a cloud. And in the cloud, we have oodles of capacity and innovation in software we could only dream of just a short while ago. And the challenge for many is to say, like, wow, like, where are we going to find the hero programmers that can scale across this entire stack? And the answer is we can't. We need many programmers. But the reality is that, you know, look at technology innovation. In the 80s, it was in the military. In the 90s, it was in the large enterprise. Since 2000s, in the consumer. The whole industrial economy has essentially not caught the wave of innovation in digital technologies. And this is now about to begin.
At a time, you know, unfortunately, when the complexity of the overall system has grown exponentially. I remember we have John DeSantis over there, who I first met, I think, 18 years ago when he was running a company called Cygate, and I was running a company called iPass, and now he's a portfolio company CEO here at HighTrust. I think about the relative complexity of a HighTrust versus the company that you built back then. It's just astronomical. It's exponential. But that traverses our whole universe. I mean, it's phenomenal, the challenge that we have in front of us, but you guys are helping us surmount it. Najib, do you want to?
Yeah, I'm thinking that essentially, I mean, the enterprise are moving to become more smart and more efficient in the way they automate things, whether on the development side, on the DevOps side, and also on the production side. And at the same time, every company is under pressure to create new services. So when you look at connectivity and storage costs being down and data, humongous amount of data being generated, how are you thinking about taking advantage of that and protecting this? Maybe each one of you can.
I can start maybe. Yeah, it seems like a simple concept, right? Like, okay, we have disks, they can store information, we gather more information, we do more with it. The reality was, I think, that has hit people over the last 20 years is that whole process is hard, really hard, because actually there's a really interesting article that was written about Jeff Dean, who was one of the founding infrastructure engineers of Google, now runs the AI group, and they were one of the first companies, maybe one of the first 5 or 10 that really started hitting scale. And when they started hitting scale, they started seeing weird errors, and they're like, "What the hell is going on?" And when people engineer a system, there are probabilities of something wrong going on. When you have 10,000 or 100,000 or 1,000,000 nodes, all of a sudden those probabilities result in one of those nodes failing every hour, as opposed to maybe every lifetime. So they recognized this and they started looking at the code, going kind of back to what we were talking about, going down the core of the machine and seeing like, oh, there's just a bit error in a memory. So dealing with that and making it work at scale to store information at scale when you have 1 billion users took 25 years of engineering and investment. So I think that's actually something that people don't recognize, is that we're just now at a point where we can really realize some of these things because of the years and years of reliability engineering and security engineering that went into building a system that can actually scale to 1 million nodes and work, right?
So it's interesting, though, because that phenomenon existed ages and ages ago at much smaller scale. So my dad worked on the SEAC, the Standards East automatic computer at the National Bureau of Standards. And it was a giant tube computer. It was in a thing the size of a rail car. And while it was running, computing the log tables and stuff for Abramowitz and Stegan, there was a guy who was walking through it and replacing vacuum tubes that burned out. And that was happening during the computation, like all the time, right? So, what counts as big scale, for fixing these problems changes over time, and we assimilate the engineering of the previous generation and treat that as a solved problem, right? So in some sense, it's good news that we have the new problems, but the task of protecting this system is sort of the reverse of that, right? The thing that we have to do is we have to radically reduce the scale of the stuff that we have to protect, right? Lots of stuff can go on, lots of computing can take place, lots of infrastructure can be deployed and run without any real protection at all, but there's got to be this irreducible minimum that protects user identities and cryptographic keys and a few other things. And really the critical engineering problem of the next 10 or 20 years is how do we shrink that down to the tiniest set of things that we can possibly work on, because we're never going to engineer protection at the scale of today's infrastructure.
Yeah. No, the thing is we worry about is on the one hand protecting our own company, but also protecting the customers who deploy this infrastructure, right? So if your electricity power generation is powered by one of our automation systems and we have a weakness in that system, you can just imagine what a tempting target that becomes for people, right? If you want to cripple an economy, you don't attack any buildings, you basically cripple the power system, and that will wipe out a good chunk of it. So we worry a lot about that, and I think internally, any Game of Thrones fans? Yes. So remember episode 3 from this season, when the zombies were overwhelming the defenses and going right into the castle keep. That's the mental metaphor that I have, which is, look, this is, assume that the enemy is already inside, assume that all of our systems internally can't be relied upon, trust no one, right? And it's sort of this constant paranoia, but we have to do this, because at the end of the day, if your electric vehicle charger is relying on our software, if your electricity grid is powered by our software, just to give you a sense of scale, like in IT, we're really happy if we can get to like 5 nines, right? 5 nines is great. I mean, just to give you a simple example of a stupid circuit breaker, if we supplied circuit breakers to our customers that have a reliability of 5 nines, we'd be killing 3,000 people a year. Now, rest assured, we don't kill 3,000 people a year, but that's because we go to 7 nines. And it's like there's this absolute obsession with health and safety. And as these things become digital, the challenge, of course, is none of these digital technologies is anywhere near as engineered for that level of reliability today. In fact, the funny joke is, people always coming from the IT side say, oh, you guys are putting sensors on all this equipment, right? I said, yes, we are. And they said, like, oh, that's great, because then it's a lot more reliable, right? I said, actually, the weak link in many cases is that sensor, because our electric motors, our electric motors last 30 years. Our transformers last for 70 years. How many times will you have to replace this sensor, this digital sensor, in the life of that asset? A couple of times, because you're going to have quantum radiation, you're going to get random bits flipping, you're going to get things fritzing out. So there is a whole system life, and the challenge, of course, is if everything is too rigid, you don't get innovation, and that's this healthy balance.
You kill 30 people a year, is that what you're saying?
Yeah. Well, I just want to know which one of the Nightwalkers left that coffee cup in front of the Dragon Queen.
Hey, there must always be a Starbucks in Winterfell.
One of my observations in the sort of big companies that I get to spend time with generally, I'm not talking about anyone in particular, I'm not naming any names here, is that there's a cultural divide. Some companies look at what's going on as a revenue opportunity. Others look at it as a sort of a cost center, IT-only challenge. And by IT, typically we're talking about internally focused, whereas on the revenue side, it's typically more marketing-driven, more. And so it seems to me I can almost pick some of the future winners or losers, but I'd be interested in your perspective of how does that game play out in the worlds that you.
Can I try that? Because this is so most, I'm a chief digital officer. Most chief digital officers, they are sort of applying, I think it's McKinsey, I blame them, but I think it's sort of this playbook that says you harvest your internal inefficiencies, that frees up money, which you can then invest on the product or business side. The problem is, I think personally, this internal side is a bit of a quagmire. And good luck if you're able to sort of just dip in, extract the savings, and then redeploy. The reality is you can spend a lifetime there. So I think personally what we've done is we've basically said, okay, that's the job of the CIO, the internal, and the chief digital officer, I'm focused on product. And therefore, we each have a job. I wish them all the best. And we can try to help with products today.
So I'll give you my perspective on this, and I'm sort of not speaking for the bank. I'm speaking as a security guy who sort of came into a bank. The way I see this is we have two kinds of money, right? We have our customers' money and we have our shareholders' money. And so if we're not spending most of that budget serving the needs of the customers, it's not clear that we're really doing the right thing, right? I mean, sure, we have to have a good enough infrastructure that our people are efficient, in creating value for customers and efficient in, protecting the operations of the bank. But, it's not my job to make me comfortable. That's not why they pay me.
Now, I mean, we have, I think, three execs here. One is in a chip company, the other one is an industrial company, and the third one is in a bank. But probably, I mean, each one of you have thousands of software engineers building products and features and services. Do you think, is there awareness at the C-level, at the board level, about the importance of software, and how are you managing the software development effort? You are probably one of the largest software companies in the world, each one of you.
Yeah, I mean, people don't realize this, but Intel has, I think, 18,000 software engineers. We're the biggest contributors to the Linux kernel, Kubernetes, all of these things. We're like the number one contributors to these things. So huge software company, actually. I think to answer the first question, Intel's board absolutely understands that now, that software is what makes things go. Again, it was that analogy, like a hardware without software is a heater, right? That's really all it does. So if you can't provide an interface that makes it useful, it's sort of like, I could give you an engine. If you don't have a steering wheel and a throttle and a brake pedal, there's not really much you can do with it. It looks cool, but that's about it. So to really derive the value, it's all about software. And I think the way we do that internally, my group is a little bit different because I think AI is a little bit different. AI is software, really. It's a type of software, really. So I think we actually are trying to monetize software even, and that's one way to do it. But mostly it's recognizing that if I don't do this, what do I lose, right? So how do I recognize value, my revenue recognition against the software effort? So that's kind of how we deal with it, typically.
Yeah, sure. So we're the world's most global bank. We're in more than 100 countries. And if you think about it, the idea that we're going to have a branch that is convenient physically to everybody who wants to be a Citi customer in all of those 100 companies is just not possible, right? We can't scale the physical infrastructure to the level that's required to serve the customer. So digital channels and the software supporting them is just absolutely non-optional, and everybody in the bank, top to bottom, understands that.
So for us, it's interesting. I think the industrial world has really, in the last, I would say, 3 to 5 years, really understood that software, digital, all of that is going to completely transform everything we do. And the way that I try to communicate that internally is I call it the Maslow hierarchy of Internet of Things. And at the base of the pyramid is monitoring. So condition monitoring, predictive maintenance, that's all down there. Today, that's exciting. Tomorrow, that's table stakes. That'll be expected of any product of any consequence. But the second level, if you can read, you can also write. And what I try to tell people is, look, the behavior of these physical assets can increasingly be changed through software. Do you want to run that robot faster? Do you want to run that transformer nearer to the limits of its performance? If so, you can tweak that in software, but you need to write, not only read. So you can optimize. That's level 2. Level 3, it's a little bit like you can apply convergence. So if you now have a circuit breaker that has software added to it, it can start doing things like load shedding. It can measure power quality. It can run building management intelligence in the breaker itself. So as a result, you're doing a little bit like your smartphone. Your smartphone has replaced your alarm clock. It ate your camera. It ate your GPS if you're old enough. These are all things that basically got turned into apps. We're trying to do the same to other people's hardware and other people's software. So that's level 3. Level 4, where we really want to play, is to try to change the business models, Najib. And this is actually what we do, what our board definitely understands, which is, what if we turned the sale of a product into a subscription? Do you want to buy a robot as a service? Do you want to try and pay for this in installments? Would you like to pay for it based on the energy savings? Would you like to pay based on usage? Would you like to pay based on outcomes? And that, in many cases, is impossible without digital. It's just not effective to even try to think of that. And we want to try and do that to facilitate the adoption, migration, and accelerate the usage of these new technologies. So we're sort of trying to climb that pyramid as quickly as we can for as many of our products as we can. And that's involving these thousands of developers, but it also involves culture change, mindsets, taking some sensible business risks, none of which is trivial for old companies like us.
Yeah, so thanks, Guido. That's actually what takes us into a direction that I'd like to pick at a little bit further. So I'm going to make a broad generalization. Don't push me on this. Let's just accept my stipulation for a second. Basically, the AI, the algorithms will become academic at some point. And yes, brilliant people will figure out ways to make incremental jumps. But in the main, if we just stipulate that, then it sort of comes down to the use cases. How will AI be diffused into the broader industrial fabric? And what will be the possibilities, the art of the possible? And I'm interested in your views on kind of, for the audience, where specifically can we go with some of that?
Maybe I'll continue since you asked the industrial use case. So what we see is, people talk about the industrial revolutions, right? So the first industrial revolution was the replacement of brawn with steam. The second was the replacement of steam with electricity. The third was the advent of computers. The fourth industrial revolution is to go from systems that are automated to systems that adapt and learn. And so that's where AI technologies really come to the fore. And what we don't believe, and this is, I think, the mistake people make, they kind of assume that we're going to go from systems that follow rules, like, if the temperature's too high, then turn on this valve, great, to, okay, we've got HAL 9000, we've got, Terminator, right? That isn't the way that things are going to turn out, we think. I think a better analogy is if you look
trying,
at...
though.
We're trying,
really
yes.
trying.
No, good. You do that. So basically what we think is it's better to think about what's going to happen is think of autonomy not as a binary outcome, autonomous, not autonomous, but as a state of continuous being, more and more autonomous. Because the AIs are going to be good at certain tasks. They're going to fail at the boundary conditions. The systems are brittle. We don't have sort of inspectable AI or things where it can sort of explain its reasoning to us yet. But they can be very good at certain tasks, and we have lots of tasks for them to apply their learning to.
So maybe here I'll be contrarian and try to incite a fist fight. And I'll say two things about AI from the point of view of a security person. The first is, we had this conversation on the National Academy's Committee on Biometrics and Privacy about, sort of what the AI is thinking. And the particular AI that we were talking about was iris recognition systems. And, fingerprint recognition systems have this characteristic that there's like features on your fingerprint, and there's a set of rules that say, oh, look, this is a swirl and this is something else and what have you. So, we were talking to the iris recognition people and we said, okay, well, what are the features that it's recognizing? And they said, no, it's not recognizing features. And I said, so in a certain sense, I hope that it is, right? But I also worry. So they told us, well, no, it just learns, what irises look like and how one differs from another. And so, we have this set of tests, and the tests say, that if you put this iris in front of it and this other iris in front of it, with a very, very high degree of probability, it'll tell that they're different. And so the question that I asked about that is, okay, well, that's fine, because that's the training data set, right? But what if you put, a marble in front of it? What does it do, right? And the answer is really hard to figure out, because just because the AI in a set of constrained cases arrives at the same answer that a human would arrive at, does not mean that it's going through the same cognitive process. And if you push it a little bit outside the boundary
it's brittle.
Yeah, it does totally unusual stuff. The other thing to worry about is, you talked about autonomy. Well, so one of the advantages of spending way too long at the University of Michigan to get my degree was that the people in the offices next to me were people like Stephanie Forrest and John Holland, who at the time, this was before they went down to Los Alamos, but they were working on complex adaptive systems. And I think, the phenomenon that we are going to start to encounter probably relatively soon is this phenomenon of emergent behavior, right? You have a bunch of these autonomous things, and they're doing stuff that's perfectly predictable if they're doing it in the middle of a factory floor, kind of by themselves, or surrounded by, familiar automobiles or air conditioning systems or whatever. But if you get two or three of them together, all of a sudden you get like a weird food fight, or stuff happens that you don't understand and can't predict. And how we are going to deal with a challenge like that, particularly if, somebody who wishes us ill, puts some other random robot in there that's doing something unpredictable in order to provoke the food fight. So we literally don't know how to think about that, and so we should be worried.
Well, I'll take that's actually an excellent segue to the kind of point I wanted to make, and it's about this emergent behavior of very complex systems. So I think I'm going to give you a little more of a hopeful view here. So
thank you.
I'm the bad news guy.
Yeah, so he's a security guy. It's what they do, right? So it's always bad news with these guys, I'm more of a dreamer, so. I think what we're seeing now is that, we went through these different revolutions, right? We had the Industrial Revolution replacing brawn. Now we're getting to a point where we can actually replace some of the cognitive or boring cognitive tasks, right? And I mean, things where you're sifting through documents and summarizing them. We can actually do that reasonably well with AI systems now. So the way I look at a human is that it's, as an information processing system, is that you have a certain capacity for finding structure within data, but the amount of data you can look at is actually bounded. You have an I/O bound problem. You can only ingest so much data through your eyes, through your ears, through your touch, whatever. You can only, bits per second is measurable. So the level of problem in which you could solve as an individual human is bounded by how much information you can take in. And maybe we can do better with neural prosthetics and all these kind of things. And then the amount of information processing we have in one head is bounded. Even the smartest person out there is maybe, 5% more intelligent than the dumbest. It's not that far off. And then what we really need to do is communicate amongst each other, and that's also bounded. My bandwidth of what can come out of my mouth to share with these other people here who have very smart brains as well is also bounded. So I actually look at AI as a way to break past those bounds, because now all of a sudden I can ingest data at a higher rate effectively because I can pre-digest some of it. So I can sift through, largely the noise structure of data and come to the part that's usable and take that in. And so I don't have to go through all that giant data set. I can let a computer do that. And so you can do that, and I can do that, and I can start communicating with you or him at a different level. We can speak a different language. So I think actually AI allows us to communicate more effectively and solve much larger problems as a species. So I actually believe AI is a fundamental turning point in our evolution as a species. And maybe this sounds a little bit wacky and weird, but 20 years from now, we'll look back and be like, wait, this was an inflection point.
I like that. That's the theory of augmentation, that it augments humanity as opposed to something else. Yeah.
It's not going to be Terminators.
Well, I mean, no, it already is Terminators.
Maybe it'll be Terminators too.
We will also have Terminators, sure. The point is,
maybe I'm working on one. I don't know.
well, all of these things, just like the industrial revolutions of the past, are force multipliers, right? And the quality of the force that you put into them and the direction that you point the artifact very much determines the outcome you get.
Yeah, and this is arguably one of the strongest possible forces in the information space, right?
Well, it's always been the case that bad people can take great technology and do horrible things.
A couple of weeks ago, I read something from Elon Musk, who is the CEO of Tesla, and he was doing his sales pitch and asking people essentially to invest in a Tesla car, and maybe 50,000 on the Model 3 or 100,000 on the other ones. And he made a statement. He said maybe in 4 years, when the new software gets loaded on them, their value would increase and be worth $500,000. So that was the first time I thought a car is appreciating as opposed to depreciating.
Let's see if that actually happens.
So, but it made me think that software in this case is really an investment that hopefully is benefiting in this case this kind of platform. But I'm sure in your own companies you think about software as adding value, as improving efficiency. So in the areas of cybersecurity, machine learning, and artificial intelligence, how are you thinking about developing and roadmaps to deliver not only to your internal employees but also to your customers?
So we have a philosophy of we buy what we can, build what we must. And I think especially even if we have thousands of people, we're still bounded, we're limited. We also have to solve all the mechanical and electrical engineering problems as well, because we believe in the combination of hardware and software. So at the end of the day, my team is a horizontal small team across ABB, which is about 148,000 people. So we basically solve some of these technology problems and then provide that to our businesses so they can solve the electrical problems and the mechanical problems and the other problems that they're trying to do to provide value. And I would say that one of the main challenges is that even for those of us that have been in the software business for 20, 30 years, things are moving really, really fast. I would say that most of our solutions that are being built now are being built on software technologies that didn't exist 5 years ago. And that is scary, but it's also one of those questions, which is like, does this get even faster, right? And then how secure is this, and how reliable is it, and will those companies still exist tomorrow when these products are still deployed out in the field?
Yeah, I think obviously we have to do the same thing in terms of the process of trying to derive more value for our customers, right? But the interesting thing is, because it's moving so fast, we have to not only react to their needs and what their problems are today. It's like, well, I want to scale out to 100,000 nodes and I care about my performance per watt. Okay, that's an engineering problem we can solve. But I need to anticipate their needs from the perspective of understanding what their applications are going to be in 5 years, because the lead time for building chips and infrastructure is years. So that's actually the fun part of my job, is actually trying to anticipate this and saying, well, what are trends that I see that are going to be table stakes in a few years? And one of the big ones is really this trend toward much larger neural network models. And this is where it really gets fun for me, because as a neuroscientist, I look at it as, we're sort of like, we're building bugs at the moment, right, in terms of their intelligence capabilities. And I want to build, a million brains. So how do we do that? You can't shove more transistors on a die. That's a problem that's got some sort of a solution, but we're outpacing that by great measures. So how do we do it faster? Well, we got to put a bunch of chips together. Okay, what do you need to do that? Well, you need some interconnect technologies and things, and then, okay, then how do you make it secure? How do you make it power efficient, cost efficient, all of these things? So these are what we kind of think about. And then how do you build the software on top of it to make it work and make that seamless? And you're doing all of this without a direct customer telling you they need it, but they're going to ask for it in 2 years, and you better be ready,
Yeah, so I guess here I'll talk about the other side of my job, which is the Citi Ventures innovation side of the job. So, so basically the way we build our roadmaps is there are two things that a bank fundamentally focuses on. The first is safety and soundness, and the second is providing, good financial outcomes to our customers. And on the safety and soundness side, at some level, we have a roadmap that's based on our vision of how we have a set of controls that that keep the attackers under control. But there is also an extent to which we are reactive to the inventiveness of the bad guys. They got to feed their kids too, right? So they get up every day and innovate. So we have to strike that balance. On the other side of the house, we're constantly looking on the providing better financial outcomes side of the house. We're constantly looking at the way our customers' use of money and financial transactions and financial relationships is evolving as society evolves and as the infrastructure evolves. And in a way, we're blessed with a lot of very small fintech startups who are showing us interesting ideas in the way that people want to use financial services, and we get to observe all of that and build our roadmaps cognizant of this discovery process that's constantly going on in the market, that we are absorbing through our innovation departments in order to inform our choices about the way our services evolve.
So I'm going to kind of go back to the AI topic for a second, and then maybe, and we're getting very close to opening it up for questions, so hang in there. One of my observations is that we are seeing the velocity of change accelerating. That's very clear. And at the same time, I'm seeing some, if not disillusionment, frustration with the ability to extract value out of AI within, traditional businesses. So the question is, A, are you seeing or sensing that? And B, why do you think that is?
Well, I think I'm sure everyone in this room is probably familiar with the hype cycle, right? You have the upswing where everybody's super excited about something. It's like all the possibilities, and you get to kind of a peak, and then you're like, well, where are the results? Then you sort of go through the valley of death. We're actually in the valley of death right now, which is a good thing, because we're actually going to come out with real solutions in a few years. So, I think I've been asked to put this in terms of a baseball game. I think we're in the top of the second. I look at more like from a technology transition that I can identify with, which was the internet. First web browser came out when I was a freshman in college. So was Ali, my friend back here, in 1993. And, I think the first real internet company like Yahoo was 1995. There's something like that. No one actually made any money on the internet until like 2000. Right. So there was a ton of hype in 1995. I remember it was just like this big deal. Anyone who could write HTML was like, God or something. But no one derived any value from it for years. And actually, we're right there. We're at that point where it's like 1996, 1995, where the technologies are there. We have interconnectivity. We have web pages you can serve at scale. Yahoo kind of could do that. But how do you monetize it? How do you build a company around it? And we're in that cycle right now. And so I think what I think is going to be super exciting, actually, from a VC perspective, is putting investments in companies that are fundamentally changing old industries in a born in AI kind of way. So Amazon is a great example for the internet. They recognize that the way they do logistics is something that they can do differently as by being an internet company and not a brick and mortar. And they took advantage of that, and you have delivery in one day now. Something like that has to happen with AI. All these traditional things that happen today, there are systems, there are markets that exist, there are demand streams that can be serviced in a whole new way. And that's, as a VC, I think that's got to be super exciting right now.
That's really interesting. It's an analogy would be companies that you have traditional companies out there trying to adopt digital, and then you have new companies who are mobile first, as an example. From day one, cloud and mobile first, and they sort of race ahead because the DNA is different.
And the old guys never catch up.
Yeah.
Right?
Very importantly.
So I guess here I'm going to channel Louis C.K. A little bit, which I realize is a fraught enterprise. But he has this great routine, right? Everything's amazing and nobody's happy. I'm a little bit confused about what people are disappointed with AI, right? So I can say, hey Alexa, what jazz shows are playing in Austin tonight? And, I'll get the answer, so-and-so's playing at Antone's, and I can say, okay, buy me a ticket. And then, I can put it on my calendar, and Google can tell me, hey, traffic's a little heavy tonight, you should leave now to get to the show on time. And then if I have a Tesla, which I don't, I have a Honda Element, it's a great car, but they don't make them anymore. If I had a Tesla, I could, be driving along and somebody could push a baby carriage out in front of me and the car would stop all by itself. It's like, what are we complaining about? It's not that bad.
So I think somebody else, I'm paraphrasing it wrong, but somebody said, if it actually works, we don't call it AI anymore, right? But I think, Naveen, just to build on something you said, there probably will be like this next generation of companies, and I think what we'll discover is they're not going to put .ai in their name. They're going to just say, like, we do this task really well. And if you're privileged to understand how they do it, you might discover there's some AI under the covers, but that's not going to be their pitch. Their pitch is, we do this task better, we do it cheaper, we do it faster, we do it to higher quality. And then I think we'll know that we've arrived and that this is now going mainstream, which is, it's become a tool. It's become something that people do.
And by the way, I mean, like, for an easy example of what you're talking about, when was the last time, a hurricane hit your city that you didn't know about 4 days in advance, right? That never used to happen, but now it's like, oh yeah, probably better leave.
Yeah, the other thing is the rate of change. I mean, Bob makes a great point. Speech recognition has made tremendous progress in a short period of time, and we're going like, how come Alexa still doesn't know what I'm trying to do? It's like, well, hang on for a second.
Changed.
Yeah. This technology was barely usable 5 years ago, and now it's like, oh, it doesn't understand my accent. Well, gee, but it has a pretty good hit rate. My wife doesn't understand my accent, so.
Unless you're Scottish.
Yeah.
But oddly enough, I use no AI devices in my house.
Yeah.
I don't either.
Because of security. I'm a little bit
me
wacky
too.
paranoid, so yeah.
I don't actually do what I just described. I just have seen people.
It's rumored to exist.
No, I've watched people do it, and I'm like, okay, sooner or later you're going to order 1,000 dollhouses, but hey, enjoy it while it lasts, right?
But I think we also, just to come back to when Bob said he was being contrarian, I think we're going to see a lot of these things, and maybe if I synthesize the 2 points, I think Naveen was making the point that AI is really good at point tasks, and it will get even better at doing that. And then Bob was making the point that, wait, be careful about the boundary conditions and the things that you haven't exposed it to during the training. And that, I think, argues for what you were saying as well, Naveen, which is like the best combination is when we have both, right? This augmentation of people. And I didn't come up with it, I wish I had, but somebody has a great term. It's called humane, where the AI is the ain, right? And I think it's that combination of the people augmented with better tools. And there's some nice examples recently that show that, for example, in face recognition, the combination of AI plus a person actually outperforms just the person or just the AI.
Well, and one of my observations is that we're starting to see things fold back on themselves. For instance, the online data and information and the online economy is actually now informing and emboldening the offline. So the example would be taking all the inputs from what's happening online that immediately goes into, in real time, into supply chain to predict what should be on the shelf 2 days from now, and which dramatically improves the margins on the offline side, et cetera, et cetera, et cetera. So Najib, I think we should open it up and see what questions we have from the audience. Matt? Yeah.
So I'm a professional investor. I mean, that's what I do every day. And so the thought, and I recently met with a fund, we actually made an investment in it, is a fund that marries just what we talked about here on the last segment, AI with the team's decisions. And so I think about how I've always done deals, which is through a network, friends, subject matter experts, people you trust, and with mixed results, right? Because not everybody gets stuff right. But so these guys are actually going about it the other way, which is letting the machine and the big data tell them directionally where to go. So they never take inbound calls. It's 100% outbound, which I think is pretty unique. So I'd love to get your thoughts on that if you have any.
You know, I'm back to the boundary conditions. You know, this is like, a lot of that stuff to me looks a little bit like rear view mirror. And the question then is like, what are the boundary conditions on which this thing fails, right? So AI is good at certain things. The question is, do you understand where that would go off the rails? Because, you know, you're just going to get a weird recommendation. You're going to get a weird outcome because you're training it on data, or you're trying to get it to make a recommendation on data that isn't representative of the training set.
And I guess I'll maybe add a little bit of specificity to that, right? Every essentially pattern recognition system, including AI, inherently has a trade-off between false positives and false negatives, type 1 and type 2 errors, right? So you can train it to never make a bad call, and it will miss a lot of good calls. You can train it, you know, to make a lot of good calls, and it'll sometimes make bad calls, but you can never completely eliminate the overlap, right? So you could probably build a system that would overall have better performance than a pure human system, but I doubt that a pure automated system would not eventually sort of drift from reality and give you degraded performance.
I think it's going to take time to build trust in some of these systems, right? It's interesting because I think we've actually already done this with real intelligences. I mean, do you trust your 16-year-old to drive? You probably give him or her a little bit more oversight than a 25-year-old driver.
I pay other people to do that.
Or pay other people, or put a GPS on their phone, or whatever you need to do, right? That's going to happen to me in about 3 years. So, yeah. So I think we put bounds around expertise all the time, right? If it's somebody who is cutting into your brain, we make them do that for 7 years. It's not that they're learning new stuff for 7 years. It's that we want to make sure they're exposed to enough weird cases and things that we have confidence that, hey, you're turned out in the wild and you make your own decisions, and we trust that that's okay. So I think the same thing has to be true of AI systems in any domain. And if you're talking about investing, I mean, you're going to come in, professional investors are going to come in with their own BS detectors, and it's like the system just continuously sets off your BS detector. It's like something's wrong. Go fix it. And eventually, whoever's building the system will come back and say, well, okay, now we got something that you think will be good. You may use it as an assistant for a year, and it's like, actually, this is pretty darn good. Then you start building trust in it. So I think this has to happen naturally. It's going to take time. It's not something that's going to happen overnight.
Yeah, I would say that you would need, along the same vein, you would need a lot of results, data from results to see what those outcomes were like before you would fully trust. Particularly in like healthcare, this was an investment, but I think it's the same thing. You would do more assessment. That is, how would you decrease the funnel? If you would go out and look for a lot of things, narrow it down to a smaller subset of ideas that you really want to look hard at, but you probably need a human in the loop until you get more data that says the system can operate on its own at supernormal returns.
But just on the healthcare one, since we looked at this also when I was at Nokia, and one of the things that people think about healthcare is like, oh, it'd be great to use this AI to diagnose people with maybe diseases, right? And the problem is like we had one case that sort of flummoxed us, which is like, okay, we know there's a lot of people that come in and they have sort of very similar symptoms, fever, headache, whatever. But that could be everything. It could be, yellow fever, malaria, dengue fever, you name it. And one of the things we know from studying the data is that there's a lot of elderly people in particular who go see their doctor quite frequently, especially in countries where you have social medicine. And what they really go to see the doctor for is not necessarily because they're ill, it's because they're lonely. And the problem is this AI is going to keep diagnosing yet other more corner cases of obscure diseases because it doesn't understand the human condition that is people that are elderly, often alone, and they like to talk to the person in the white coat, and then, it's pretty easy to go and see them. And so off they go.
Yeah, and
Those
like
are inputs,
that
though.
null hypothesis thing is really important, right? So that you're training the AI on the basis that people who come in to see the system are sick, right? And ain't always the case. And that gets built into the model.
Other questions?
Thank you. And I've found AI to be extraordinarily beneficial, not in garnering revenue that you talked about, but really, and someone touched about it, doing things cheaper, better, faster. I mean, some of our high-cost employees, we've augmented them by 80%. So that makes a huge difference. And not only just the cost, but the quality's gone up, and the speed has gone up, and the costs have come way down. So I think people, and behind the cover, it's maybe not driving revenue, but it's certainly saving or helping the bottom line dramatically. And I think people oftentimes get, artificial intelligence confused with machine learning and then deep learning, right? I mean, that's sort of the next step. And I think artificial intelligence is working on almost any company is using it. And to your point, even in your households, you're using it every day. But it seems maybe the deep learning or machine learning is a little slow. And the question I have is with quantum computing. I just read an article yesterday that Microsoft is opening their quantum computing software, open sourcing it basically. And is that going to maybe move the needle on some of these other things? I know enough to be dangerous, so I'd love your thoughts on quantum computing.
Yeah, so last night we had an event at Citi Ventures where we had, among others, Microsoft and representatives of other companies in the room. And there's a lot of, and I was on a National Academies panel on quantum computing. I was the designated dumb guy on the panel. I was the security guy, right? I'm here for the bad news, right? Oh, we have a bunch of physics over here. Oh, yeah, that's frightening. There's an enormous amount of progress in quantum computing right now, not just at the level of synthesizing quantum computer machinery, but also at the level of building hybrid algorithms between quantum and classical computer architectures, at the level of figuring out how to run reliable algorithms on error-prone computers so you don't have to fully solve the error correction problem, figuring out how to run interesting problems that we tend to frame as digital problems on analog machines like quantum annealers and what have you. So the indications are that quantum computing is definitely going to have a big effect at some point in the not too distant future. And how many years do you want to put on that prediction? I don't think it's nuclear fusion, which is 20 years from now and always will be, right? I'm hoping it's not shorter than 20 years because I need 24 before there's a quantum computer that can break public key encryption, because we got a bunch of work to do to fix that problem, right? But I mean, that's the order of magnitude, right? I mean, we're talking somewhere between 5 years for initial commercially interesting problems to 20 or 30 years to a really big effect. It seems to be the consensus guess.
Yeah, I think quantum is promising. It's not even clear yet if classical machines are worse or better overall. So the jury's out, and I think there are different kinds of quantum computers, the annealing machines, and in fact, deep learning. So machine learning is a superclass. AI is even bigger superclass, and deep learning is a particular type of machine learning. So deep learning can actually be somewhat posed into these annealing problems, which can potentially be solved by a quantum machine. Now, I always look to biology when we don't have a good answer, because you can look at 4 billion years of evolution and say, what happened, right? As a trained neuroscientist, I can look at a cortex from a rat and a human and can't tell the difference. So the fundamental circuitry of both are about the same, but clearly there's a difference. I think most people would agree. And it's basically about the multicellular architecture of it. So I actually think there's a lot more that can be squeezed out of a classical machine. So I'm actually not in the camp of quantum's going to kill everything. I think classical machines got a lot more to go, and Moore's law kind of The non-reliance on Moore's law is going to open up a whole bucket of creativity on how to build better machines.
Well, actually, I mean, that's one of the best effects of quantum computers so far, is that every time somebody comes up with a quantum algorithm that seems to offer a lot of speed up, so the classical
Somebody comes
guys
up with
get
a
all
better
pissed off and they say, wait, I can do that better. They
implement it.
And they produce a better classical algorithm. So, the non-existent quantum computer has already driven actually a significant amount of progress in classical algorithm.
But the other thing, I mean, to Naveen's point, Naveen is the neuroscientist, I'm not, but I'm the electrical engineer. So think about the human brain. Your brain consumes about 60 watts of power, okay, in terms of energy. And you can be playing a game of Go, digesting your meal, and thinking about your kids all at the same time. So we know that to play the game of Go as a master Go player does not require all of those 60 watts or they'd be dead. I mean, they would just basically not keep functioning as a person. So the approximations we're using today for machine learning, we require like entire racks of compute consuming hundreds or thousands of watts. We're off by orders of magnitude in terms of the models we're using to do machine learning today. If we got better at understanding that, and I hope maybe the answer is not that, oh, it's quantum at the neural level, but if it's not, I mean, look, human neurons only switch like a couple 100 times a second. They're very dense. We have a lot of connections and they're very dense. And they're very energy efficient. But in theory, we should be able to make it even more efficient and faster in silicon than we do it in wetware today. So there's huge progress still ahead of us.
I think Bill Dayat, one of our Sway CEOs back there, has a question.
A question and perhaps interest in how you're solving the challenge.
By the way, he's the CEO of Mokana.
Yeah. So we've talked an awful lot about the promise of AI, the things that a machine can do rather than a human. We talked about the limitation of the human brain in terms of an I/O block, if you will, or a limitation. Organizations are made of collections of human brains. So the question that I have is, what do you see, and in particular for ABB and Citi, what are the things that your organizations are doing well to accept generationally breakthrough technologies, and what are the things that they need to do better to accept them faster in a situation where you have organizational and human challenges around a machine maybe doing something better that an engineering team of 1,000 has done in the past, the difference between safety on the industrial side, the risk management side on the banking side, with a new technology, putting that all in play. How are your organizations tackling that challenge today and in the future?
Okay, that's a lot of questions in one. First of all, one of the technologies that I'm pretty excited about, because we have definitely got this generational challenge, and I would say that our customers in some cases even more than us. Just to give you a nice little factoid, the average age of oil workers in Houston is 55. 50% of those people are going to retire in the next 10 years. They're going to have a massive brain drain. So the question is, how do you transmit knowledge from one generation to the next? And I think there's actually a really cool technology that we like a lot. It's not anywhere near as advanced as quantum or AI. It's just augmented reality, right? So the notion of you strap on a set of goggles or you look at it through your tablet and smartphone, and a reasonably qualified technical person can now be guided through the task that otherwise a supervisor or somebody looking over the shoulder would guide them through. So all of a sudden you have a generalist who can do the task of maybe 10 specialists previously. So it's a sort of a force multiplier, I like that term, of trying to promote skills. The other thing that I think we need, and maybe this does stray back into AI at the moment, I really liked, I think it was Andrew Ng who recently wrote an article where he said that in addition to creating AIs that produce a prediction, they also produce a confidence factor based on how representative this current data that they're looking at is of their original training set. I think that's also quite good, because if you have a system that says go left and you're saying like, all right, you're saying that because you know or because you think that it's the best answer you can come up with? And I think we lack that today, right? There's sort of this confidence of how are we at the boundary of your knowledge, or are we in the middle of your knowledge set? And if we had better systems that also convey that, then the humans in the loop can say like, all right, hey, let the machine do its thing, right? I trust you. Versus maybe not, maybe I take over now.
So actually, you hit on sort of what was going to be my answer to the pre-circulated question of what keeps you up at night, right? I mean, what keeps me up at night is the ability to hire enough people to perform the security task in the future, right? There's already a huge shortage of them, right? It's as an industry, we're not doing a good job even replacing, old guys like me. And bringing up enough people to fight the battles of the future is an unsolved problem generally for everybody, right? For the entire industrial sector. So from my point of view, right, every task that we can offload, from a security analyst or some other professional onto an AI or any other automated system, shell script would be fine, frees up some part of the day of one of those skilled workers to, backfill some of this shortage of personnel, which gets worse and worse and worse for every major firm every year. And we're intentional about, trying to plan for that. To answer the other half of your question, how do we assimilate all of this change generally? Well, we have, at least two institutional vehicles that are dedicated to exactly that, right? We have Citi Ventures, which doesn't just invest. We also have an internal innovation programs and quite an extensive staff, which is, promoting adoption of new technology, internal development of innovative techniques throughout the institution. We also, in security specifically, have an innovation lab, which one of its purposes is to evaluate new technologies and figure out if and where they fit into the operations of the bank, and that's a global mission. So we have organizational structures which are designed to help us address those challenges, right? And as usual, every organizational structure exists in a perpetual state of imperfection, so we're constantly also trying to improve them. Yeah, no, it's a profound challenge, and the challenge is compounded by the fact that both our infrastructure and the threat get more complex every day, right? So the real question, I think, is the one that I talked about earlier. How do we simplify both the problem and the solution so that it can continue to scale with both the complexity of the infrastructure and the sophistication of the threat? So that was the other thing that was going to keep me up at night. So I don't mean shrinking in the sense of Land of the Giants, right? The old TV show where they actually shrink humans down or devices or whatever. What I really mean is reducing the collection of stuff that has to be protected to the absolute minimum so that we can spend our resources on doing an outstanding job of protecting a few things rather than doing a mediocre job of protecting everything.
So, gentlemen, I'm sorry. We'll let you have the last word. Go ahead.
It's really quick. I mean, my dumbed down version as a non-security expert, but has to get the security briefing from my security guy, is that the threats actually are very specific to the kind of technologies you're dealing with. So like AI actually has a whole set of threats that are really interesting, like spoofing training data and changing the way systems can actually learn and stuff like that. So I think it's really important to understand the specific vectors that are relevant to the technology you're working with, and then zeroing in on reducing the space, just like Bob's saying.
So, gentlemen, this has been great, and I sincerely appreciate, on behalf of Najib and I and the rest of our partners at Sway and the audience, I'm sure. Thank you so much.
Yeah, a few closing statements from Brian.
Yeah, thank you. How about a big round of applause for our panelists? Another thank you to our sponsor, Hughes Marino. Big round of applause. David, it's great to see you guys in San Francisco where you belong. Thanks for coming tonight, you guys. Tonight is the eve of our big conference, Sway Minds, tomorrow. Many of you have been there before. For those of you that haven't, you're in for quite a treat. About 250 of our closest friends are going to show up across the street at the Battery, and we've got an incredible day of content for you. Tonight is a pairings dinner. We do these probably once a quarter, and we try to pair great people with great wines and great food, and then put some people that are a lot smarter and knowledgeable than we are up front, so that hopefully we can engage and learn. So hopefully tonight you guys benefited from all of that relative to pairings. Definitely see some familiar faces out there and some new ones too. Have my co-founder Bill talk for a brief moment, just a little bit about Sway and what's happening with us.
A part of that question is, what defines us at Sway? It's interesting as we look back. What defines us is we're really looking for high-performing teams that are defining categories, whether it's enterprise or consumer. And Uber is an example, right? If we all remember when you had to slog through taking a taxi and how miserable that experience was, they really redefined how we get from point to point, and we're fortunate enough to be investors there. Carl Showalter is here somewhere. As we think about optimizing warehouses, trying to get people that used to drive forklift to do higher jobs that can actually use their brains instead of driving forklifts around. Bill at Mocana securing engine turbines on airplanes for us. So I think we're fortunate enough to work with some of the brightest founders and engineers, in San Francisco, but we've expanded onto the East Coast. We've got Carl and Arno manning London and Stockholm. So it's been a great journey for us. I think as you guys think about tomorrow, we're going to kick it off. Brian and I will try to keep it short and sweet with a quick intro, and then you've got Steve Guggenheimer, who's head of Microsoft's AI group, to come in right behind us. So you're going to hear really amazing things. We've got some artists and entertainers that are going to talk, even hear from a neuroscientist talking about how we can all try to find a cure for cancer. So a lot of really interesting things. I think thank you all for coming tonight. Kind of give it back to Brian to close it.
All right, guys, thanks for coming.